and now use that background in the big data space. So
Mike,
big data.
we're unable to see your presentation. Would you be able to see what's going on over there? There you go. Perfect.
Still on welcome screen, but thank you for the reminder.
No worries.
So, quick wrap. In the big data, we have, many of the same challenges we experience just in our traditional data centers themselves, right? Too many passwords, complexity of passwords, dealing with security. When big data first came onto the scene several years back, the assumption was that if the solution was behind the firewall, it was safe. So security was really kind of second problem besides making the solution itself work. So there wasn't a whole lot of effort put into securing the environment. Once it got to the production level, of course, security admins and so forth really put the brakes on that and said, okay, well, we can't just do that. We have to have security behind their solution. This is a huge honeypot of data, so we need to protect it accordingly. And so they started going down the road of dealing with Kerberos and securing the environment better, which then implemented its own challenges. So Centrify is just a background on who we are. As I mentioned, we're in the identity security space. So we focus on a number of different issues, and I'll bring up the slide deck here. Right, as we talk about challenges within the identity space, it really comes down to kind of two key main areas where we have passwords, you can see on the one axis, and privilege and policy on the other. Right, so organizations who are in this high-risk area, have too many passwords. Users are constantly asked for a completely different set of passwords. There's multiple identity silos within the organization, both inside and out, especially as next generation SaaS applications become more prevalent. Users are just over inundated with password use. And then so that leads to password reuse and sharing, and it's just kind of a general mess. And then we also have basic authentication as an issue. Right? If your password is the only thing stopping a hacker from getting your data, they probably already have your data. Using just simple basic authentication with a password in these days just isn't sufficient. So using something like multi-factor authentication really helps prevent that type of access. Too much privilege is also an issue, right? Users today are logging in onto systems with highly privileged accounts, whether it's a local administrator, domain administrator, root level accounts, and they're doing so interactively, right? And so if you were going to steal someone's data, usually the first step is an automated attack. I'd send you a piece of malware to execute a piece of code, and if you have any real privileges on that system, well, now so does that piece of code. It can install itself, stop services, attack your network settings. You can do all of those kind of things if you have the rights to do that out of the box. And so not having any context behind that, not having auditing behind that, you can see where the danger really lies there. So as organizations get a little more organized, they start layering in, better options. Single sign-on for SaaS applications so that users aren't having to type in a multitude of passwords throughout the day or maintain those. So they're not writing it down and reusing, using things like multi-factor authentication, proxy-based sessions, and elevation. Right? And then as we move on, we get even better, right? Using MFA everywhere, using least privilege, using consolidated identities and user-level auditing so that we can gain all the benefits of securing our environment, both from a least privilege standpoint and multi-factor authentication standpoint. And so that's what Centrify focuses on. Right? We have the ability to protect any number of devices from any device, for all users, and that's essentially what we do as an organization through 3 pillars of products that we have. So just to give you a quick overview of what we're talking about here, we're mostly going to be focusing today on the server suite. Right? So this is our Active Directory bridging component, least privilege, elevation. Right? So this is really going to be important to the big data environment. This is really the core in helping the Hadoop environment simply join to the Active Directory world in a much more robust way, and then implementing things like least privilege and multi-factor at that level. But there are other components that we have within our tool set that can also help within the Hadoop environment. For instance, the identity service is really a single sign-on solution, right? So we talked about SaaS applications, a single portal where a user can log in with their Active Directory account and get to any web-based application, whether it's inside or out, without having to retype a password, whether that's SAML-based authentication or username and password. So for the Hadoop environment, that can be very important for providing access to certain configuration consoles, right? So like Mbari for Hortonworks or Cloudera Manager, MapR Manager, all of the main web components that manage your clusters can be given access for a user who's perhaps working from home, or a contractor who's working remotely can get to those type of consoles without having to open up a VPN connection or giving them access to a much wider range of network components when they really only need access to that one web console. Privileged services are a version of a password vault. It's cloud-based infrastructure, so no matter where your clusters may lie, whether you're hosting them on-premise or have a private cloud solution, which is becoming more prevalent, we can manage all of the local accounts as well. So we'll deal with the Active Directory identities, local accounts and service accounts, as well as the ability to deal with single sign-on for web applications. Right? And so we have this one single platform, and all these tool sets work together. Right? We've never made an acquisition as a company. We built all this from the ground up to work perfectly together. Right? So whether you're talking about logging in with your Active Directory account, managing your password and credential, or secure remote access, or single sign-on, they all share the same underlying architecture. Whether it's the cloud directory, the authentication, workflow, multi-factor, one single platform for managing all of those components. Right. And so, again, the benefits here, we have increased security, improved ROI because we're not dealing with multiple silos of authentication. We have workflow, and we have continuous compliance. We can do monitoring. We can actually validate and check what our privileged users are doing. So that's the end of slides. I'll focus more on the actual data. I'm sure that's what everyone wants to see anyway. So I'm going to quickly log into one of my servers here. And this is our Centrify Sds Lab. This is sitting out in California. And we have here all three cluster environments. So we're talking about Hadoop. We have Hortonworks instance, we have Cloudera, we have MapR, and we treat them and work with them all the same. In fact, we have working relationships with their development teams to continually improve the product from both standpoints, from their tool set working better with Active Directory and our tool set working better with their tools to make sure you have things like Kerberos renewals and lots of different capabilities that go beyond a traditional server that are very specific to Hadoop. And so we built all that into our product as well. So within the Centrify Server Suite, which we talked about, or I mentioned quickly, we have this concept called a zone. Right? And so a zone is a way for us to structure the policy for all the various components. Right? We have computers that we want to protect. If we're dealing with Unix boxes, we're also going to have to deal with identity mapping. Right? An Active Directory user can't just log into Linux. They use a completely different security ID format. You need things like home directory and shell configurations for a Linux system to recognize the account as a valid user or group, right? And so what our identity mapping allows us to do is customize that mapping. So that way, the system will only see the particular users we want it to see rather than every single Active Directory account. And then for each identity, we can even custom configure each of those attributes, whether it's the UID, the home directory, the shell, whatever it may be. And we could do multiple mappings for a single user. So if different groups of systems need to see a user in different ways, we're not restricted to a single mapping. We can do multiple mappings per user. So we have much more control over any of the open source tools or just kind of generic Ldap read of Active Directory. Here we can actually customize and configure what we want our enumeration to look like for various systems, whether it's just a single cluster or maybe your entire data center. Right? Either would be appropriate. This newer 2016 version also includes the ability to provision local accounts as well. So if you have certain applications accounts that need to be created locally because some application has hard-coded against FC password, you can simply add it to the zone here, and when the system joins the domain, those accounts would be automatically created on those systems. So various capabilities around mapping. And then lastly, you have this authorization capability, right? So it's not just authentication, but it's authorization as well. The ability for a user to be able to elevate certain commands and rights in a much safer way than giving them full privilege access to the system. Right? So today, if they're logging in as root, right, you're still susceptible to those types of automated malware attacks where it's going to try to use your credentials against you. But by switching to a least privilege model where the user logs in as themselves, stays themselves throughout the whole day, and has only enough rights to do their job, then you prevent that type of attack. And when you do provide any level of privilege, what you really want to do is simply elevate the process that the user is trying to execute, never the user itself, right? So that even if they are attacked by a piece of malware right in the middle of executing some sort of privilege, the token for the user really still doesn't have anything special. They can't install software, stop services, or attack your network. And so that's really the whole idea behind using least privilege authorization. In the Linux world today, you have some of that using sudo, though most organizations typically just use it to sudo root immediately, or don't have it very well defined. In larger organizations, it becomes very difficult to manage a decentralized architecture like that. So what we did is we built it all into Active Directory. Now it's a centralized policy where we can manage it all together along with the machines and users and put those pieces together. One thing you'll notice here is that we also have what we call a hierarchical structure, right? So we have a zone here at the top, but then I've also created child zones for each of my clusters, right? So I have my Cloudera, my Hortonworks, my MapR, and we even have a lab environment for SAP. And so what this allows us to do is pick and choose what's appropriate for our configuration, right? So if it's something like identity mapping, like I want this user to show up, I now have a choice by using this parent-child relationship whether I want to map a user across all clusters by mapping it at the parent and having that inherit down, or I can map something at the child itself, and that would be only applied to that particular set of computers. And so it gives us much more control as to how we want things to work, and without making redundant tasks for the administrators. So that's the kind of general background on what we're doing as far as identity mapping and computers go. So once we get into it, we have our various clusters. So I'll just pick one here. We'll open this up. Let's say Hortonworks. Okay. So if we go to Hortonworks, we go to Ambari. And when you start out building a cluster, it starts in an unsecured format, right? Meaning that basically any recognizable user by that Linux system can submit a job, read data, do anything it wants within the Hortonworks environment or the Hadoop environment itself. You can ignore all that. It's just me being off for a couple days here, but everything should be fine here. And what we have is the ability to then enable Kerberos, which I've already done here. And so by enabling Kerberos, the system is going to move from using local accounts, local application accounts on each individual Linux system, to a Kerberized environment, meaning that it's going to create service principal objects within Active Directory. It's going to create key tabs that are then going to be distributed and stored on each of the Hadoop nodes, and it will use that to spin up all of the services. And so from that point forward, absolutely nothing will work without a Kerberos ticket. So even though a user is recognized, it will have to have a valid ticket, a valid home directory in order to submit jobs, and that's where you can start securing exactly who has access to these systems. By using the Centrify model, we can determine exactly which users are going to be enumerated, which ones are going to be given access to, let's say, log on to the system, because we can have various roles. Like, do we want a user to just be listed and actually be enumerated by the system? Do we want them to log in? Do we want them to be able to elevate certain commands? Right, so all of those are options for us that we can configure within the Centrify environment, which works perfectly with the Kerberized environment that the Hadoop distributions are now implementing. So let me jump onto a box here. We'll stick with Hortonworks for a moment. I'm going to go ahead and log in as an Active Directory user called cluster admin. Now, cluster admin is just a standard user that I created. Type in the password here. Okay, so I've logged on as this Active Directory account, right? Pretty straightforward and easy. I just simply typed in my Active Directory password. If I wanted to at this point, I can also implement something like multi-factor authentication, where I can either use a token of some sort, or I can integrate it in with our identity services and use something like my cell phone, right, which is registered to my identity, and I can get a prompt that says, someone's trying to log in as you right now. Do you want to approve or deny that request? If I hit approve, then they would go ahead and do that. So I can use these secondary tokens, or perhaps even use something like email or SMS or a predefined security question, all sorts of various options that we've integrated with this. So whether it's something as simple as authentication or the elevation of a command, we can use this to provide multi-factor everywhere, wherever you need it. In this case, I just used pretty simple username and password. So to give you an example of elevation and how the Centrify tool works there, I'll use a very simple command. We have a utility called AD-Flush that simply refreshes our cache. And so if I were to run this, it yells at me and says, you have to be root. Well, what I did here was I gave this user, I added this user to a group that's been given elevation privilege. So if I do a DZ-do, which is our version of sudo, and do a -L, it can tell me what rights I have here. And it's here, and it's actually asking for secondary factor. Right, so in this case, based on my group membership, if I come back to here, right, I have this Unix full admin role that I have created, and basically it has one right. Right, so I can make this as simple or as complex as I want. In this case, I wanted to give the cluster admin root level access to the system without ever logging in as root itself. So here, I'm allowing the user to elevate any command in any path, right? And he's going to do so as root, and I can put all kinds of, secondary factor, allow or disallow child processes, whatever I want to create as a right, I can custom configure here. And so here, the user has the ability to elevate anything they want, but I can make it much more granular than that. If I want it to be just a single command, for instance, our AD-Flush utility, I can put that in there as well, right? And then same thing, I can elevate to root, I can elevate to an application account, and I have all of that capability. Once I have the right, I add that to the role. Within the role itself, I can custom configure elements like time. I can say the user can only run certain commands, maybe during a maintenance window, or they can only log on during business hours, for instance. I can get down to that level of granularity. Same thing for auditing. The auditing is all tied to the role itself. So here, I can pick and choose what I want to record and when, right? So if I turn on auditing, like let's say at the login level, then I'm going to record everything, right? Everything you do from the moment you log on to a system to the moment you log off is going to be recorded, and I can go ahead and play that back and have that forensic data determining exactly what my privileged users are doing. So for organizations who are managing like PCI data, maybe HIPAA data, right? This is crucial, right? Being able to provide replay of those privileged activities to be able to determine exactly who had access to your data and what did they exactly do with it is part of the game now. You just have to do that. So our auditing solution ties directly into that role capability. And then lastly, we take those roles and we tie them directly to an Active Directory group. Right, so here I have my admin role, and I created a group associated with it. So all I had to do was simply add my cluster admin user, which is a standard Active Directory account, to this standard Active Directory group, and now I have that capability on these particular systems that are part of that zone structure. Right, so coming back to here, now if I want to elevate that AD-Flush command, I can type in DZ-do, AD-Flush. And now what's going to happen is it's not going to change the user. The user context is still going to remain in that least privileged state. But what I'm doing is simply adding the root token to AD-Flush command itself. So only that one process is elevated, never the user itself. Right? And so now it successfully did that. And because I just typed the password, it didn't ask me again. So you have that typical 5-minute window to retype a command without having to re-enter your password. but generally this role requires secondary authentication so that someone can't walk up behind me and start typing in commands, right? So that's the whole general idea. We take care of the user identity. We take care of the least privilege elevation at the operating system level. From there, the user has, as part of logging in with Active Directory, a Kerberos ticket, right? So now, when I want to submit a Hadoop job, that's no longer a problem. I already have a ticket to do so. And so it would allow me to then go ahead and run a job successfully, and it's all based on that security. What Hortonworks and others have begun doing is also creating Active Directory integration for a lot of their utilities. So for Ambari, for instance, they have a new feature where you can now go ahead and import all of your Active Directory accounts into their database and then authenticate directly against Active Directory, so you don't have to log into here as your typical traditional admin that gets generated when you start. You can actually use your individual accounts to log into the Ambari consoles and manage the cluster. Same thing for Ranger. So Ranger is another utility that Hortonworks has that allows essentially table level security within the cluster itself. Right? So you have all this structured data, and so you can go ahead and block Active Directory users from accessing one component or another, at the application level. So we take care of the operating system, they take care of the application layer, but again, you need that integration between the two. And so our utilities allow us to do that. One interesting component that we do add beyond our traditional, authentication, authorization, auditing, is an Ldap proxy, which comes in very, very handy in the Hadoop world. So to explain, when we store information inside of Active Directory, right, what you end up having is you have traditional user accounts, right? So you have, let's say, this cluster admin account I have, right? Traditional security principle has a username, has a password, that kind of stuff. But when we start doing identity mapping, let's say creating an identity for cluster admin so that he has a UID, a home directory, a shell, any type of real-world Active Directory bridge solution is going to store the information a little differently, right? It's not just going to store that information inside of that user object. Because if we store it in just one location, then we're limited to one mapping, right? And then you also have to give whoever's managing that a higher level of write permissions to that object, which organizations sometimes don't want. And so in a traditional identity mapping structure, what we have is the ability to create what are called service connection point objects to represent those users. So if I take a look at the zone structure and I go to my users container, right, there is an object in here for cluster admin somewhere, right, along with all of our IDs. And so cluster admin here has this service connection point object, and if we take a look at the attributes of that, you're going to see, here is where all that mapping data gets stored. So we have our UID number, our home directory, our shell, it's all stored in that object, right? And so if something is just doing a generic Ldap read saying, find me this user and give me the properties for UID number, for instance, it's not going to get a good result because the information is stored in two separate locations. And so what we've done is created an Ldap proxy to sit in front of that. So now organizations like Hadoop or even storage vendors, for instance, they need to read UID data. So for all of those different types of lookups, rather than going against Active Directory itself and trying to figure out where to start, where to end, which objects to look up, and where to find the data, we can just simply point it at an Ldap proxy, and it can talk traditional Ldap RFC 2307, meaning that the standard for UID and all the various attributes are in one common format. And so it can talk to our Ldap proxy, and then it doesn't matter what's on the back end, right? How many mappings the user has, whichever zone that machine is joined to where the Ldap proxy is running, we'll give it that pre-filtered data, right? You're going to get only the users who have been properly enumerated. You're going to get all of the various properties that you need in standard Ldap format, and off you go. And we can simply tie that into Active Directory CA as well, and even do 636 or LDAP connectivity, which is one of the requirements that Hadoop needs to actually create the cluster in the first place. So our Ldap proxy contains both a server and a client component, and the client component is then used to talk 636 out to Active Directory to create the accounts in the first place. So what you'll end up seeing is that once you give it the Ldap proxy, the cluster itself, once it creates the accounts, is going to look like this, right? It's going to create all these various accounts. So where it used to use local FD password accounts to manage these services, now it creates what's called an SPN account. So service principal in the Kerberos world simply provides the information to the principal that's being used. So we have all these various services that you can see, like HTTP, Spark, Yarn, Zookeeper, right? And these may be running on one or more instances or nodes within your cluster, right? So Cumulo, in this case, is running on all three. And Bari is only running on one, right? So you can see that where the services exactly lie. And if you take a look at this and go to the properties here, go to the attribute editor, open down the service principal name, right? There's just a single principal for each account. And so these are not accounts that anyone logs into. They're just simply accounts that are generated by the cluster to create that service principal name. And so what happens is it also creates a set of key tabs. Now, key tabs are basically an encrypted version of your password, and they stay local to the system. And so what happens is when the service spins up, it uses that key tab that's been generated on that system with the pre-known password, and what it's going to do is just make a request out to the KDC using that token or the AD key tab to encrypt that traffic. Now only the KDC can decrypt that, and the message return can only be decrypted by a valid key tab using the correct password, right? And so that's how Kerberos works without sending passwords over the wire. That's why it's a more secure technology than anything prior, where it just sent a password to a single directory, and the directory said yes or no. Right? So the cluster will do all this work for you, right? You go into Ambari, it will create all the various records based on your cluster configuration at the time, and can then go ahead and create those key tabs on the local systems for you as well. And so what we can also do is we can also create our own key tabs. And so for here, I've created one for HDFS. HDFS is the file system, so if we wanted to let's say create a new home directory within Hadoop for HDFS, that would be impossible to do with the local account, right? Prior to clustering or securing the cluster, users would just switch over to the HDFS account using a standard SU, and then they would just go create a home directory, and that would work. Once you secure the cluster, that no longer works, right? So here we can create a key tab and just do a KINIT to assume the identity of HDFS and actually have a Kerberos ticket with that proper format or service principal, and now creating something like a home directory would work fine. So lots of various capabilities of using the Ldap proxy for reading and writing from the directory. So let's see if we can pull up an example of that here. So here I'm the cluster admin, and if I wanted to read out what was happening within my environment, sorry, it's probably going to be a blank portion there for you. Just steal a copy so I don't have to type. So the Ldap proxy search gives us the ability to then search the Active Directory environment using predefined information, right? So I'll do that. We're going to go to CD. I believe it's user, share. Okay. And then we're going to go ahead and run our Ldap search. And so you can see what we're doing here is making an Ldap search again, Ldap S386, and we're going to point to the local host rather than Active Directory because we have the Ldap proxy running here on this host. So it's going to talk completely encrypted traffic to here, and it's going to use the administrator account for the domain to authenticate, which is a requirement, and then we can add our search filter. In this case, we're going to look for POSIX account. So find me any identity with a POSIX account object class, and it's going to return all of our users, right? So in the Unix world, POSIX account and POSIX group are our two main components that we want, our users and our groups. So by simply searching for this, what our proxy is going to do is, in this case, ignore even going out to Active Directory in the first place, because we've already cached all the necessary user data onto the system itself. So, until the Hadoop world just starts reading against PAM directly, we can trick it by pointing it to the LDAP proxy and giving it only the information it needs. So here we'll run that. We're going to type in our Active Directory password here to authenticate. Right? And we're going to get all those results, right? And so here, all of the users who were mapped in the zone are now given as a result, right? Nothing more than what's in the zone configuration, because we don't care about anything other than that. These are only the valid accounts that are appropriate for this system, and so it gave me all the information I need, right? So for things like Ambari, where you want to do integration, you can point it at the LDAP proxy, and now we have our pre-filtered list of users that are going to be imported into the database. Same thing for Ranger. We can use this not only for creating the cluster security in the first place, but then using it ongoing for this type of integration and activity. Anything that needs information from Active Directory, point to the proxy, you're all set. Much easier to deal with. So that's the example of all the various aspects we can use within Server Suite, where we can use it for authentication, we can use it for elevation, and then we have the auditing capability. So the audit analyzer gives us the ability to then go in after the activity has been done and figure out what our users have been up to. Right? So today, there's this predefined query here for activity today. There's only been one login. This cluster admin logged into this node. And so if we wanted to see what was going on, we can see that it started here at this time, and there is no end time. It's still in progress. So we can actually open that up. And what you're going to see, once it does, is you have two sides of the console here. The right side is the visual representation. Think of it like a DVR, where you actually get video control of the session that you want to monitor. And so it has, fast forward, rewind, just jump around, double speed, all that kind of stuff. But on the left side, you also have a printout of all the various actions that took place during that session. Right? So it's all time-stamped, and we have all that nice clean metadata. So when we want to look for a particular action, whether it's across this number of users, across a number of systems, or even within a session, we can use that metadata to filter down and find exactly what we're looking for. Now, since the user logged in a least privileged state, maybe I only care about privileged activity. So I'll just search for DZDo. It'll filter down that list, and you see those 3 different actions that took place, regarding DZDo. I did a -L, typed in my password, and I also ran a DZDo 80 flush. So if I was interested in seeing what happened with this command, I could just simply double-click on it, and it's going to fast forward right to the portion of the session where that occurred, and I can see all the input and the output of that command. Right? So you have full forensic replay of all of the actions that took place during that privileged session. So users can't just go off and do things and expect to not be tracked, right? And it's much easier to deal with than kind of your standard syslog, which gives you thousands and thousands and thousands of lines of data constantly streaming from each system, which may be harder to figure out exactly what a user did. Whereas here, you have this nice session view where you can actually just replay it like it was a GoPro sitting on the user's forehead. So here we get much better forensic detail on exactly what's going on. So it's all part of our Server Suite as well. So I'll quickly touch on some of the other components, and then we can open it up to questions, and if someone wants to talk about a certain topic, we can do that as well. So lastly, we have the other components. So I talked about privilege service, and I talked about identity service. So identity service is a privilege solution that allows us to go to SaaS-based applications. What's cool about our architecture is it's both inside out and outside in, meaning that it's a two-way street. So if an inside user is just trying to get to, let's say, an external application like WebEx or maybe Office 365, we're going to act as a federated partner for you. So you'll click on the link. They'll have probably SAML configured. They'll come back to our cloud service. We'll authenticate against your own Active Directory to generate the token, and off you go. For simple, the websites like, let's say, my Marriott page, I can also just put in my credentials and store them here as a vault, and then it will just simply enter those credentials when I click on the tile, and then I don't have to type in my password again. So even if I had a completely different username and password for each website, it really wouldn't matter. I would just log into the portal once with my Active Directory account, and I'd be able to gain access to all those outside applications. But as I said, you can also go outside in. I'm sitting in Florida, right? Our office is in California. And we have certain utilities that we don't publish to the internet, right? Maybe an inside SharePoint instance. We have this utility Bugzilla that we use for all of our development efforts, right? So if there's a bug that I have to file, I would have to go use this utility. Right? So I can click on that, and without a VPN, I can go right in and access that application and have single sign-on. So the same concept would then apply to things like the Ambari web page or Cloudera Manager, MapR Manager, any of the tools that you want to provide access to without giving a user or a contractor VPN access. You can even give them customized configuration access or authentication into the portal itself. We can choose to authenticate them against Active Directory inside, or maybe we just want to keep them outside entirely, right? We'll just create an account for them for the portal using our own cloud directory rather than AD, right? So we can keep users out entirely. So what this includes is the ability to integrate mobile devices as well. So you get a full MDM solution as part of the deal. So you can do all of your general access of remote wipes and locks and container management, figuring out where your device is located and all that good stuff, and pushing applications. But we most often use this as a two-factor authentication. So I talked a little bit about the mobile integration earlier. I'll give you an example of what that looks like. So here we have Concur, which we use for expenses, and you can see there's this little lock symbol here. And that means two-factor authentication is going to be required. So if I click on Concur, it's going to authenticate me. It's going to do its little handshake. And so now it already authenticated me and knows who I am, but it wants a second factor, right? And our policy gives me all of these options. I can either use my mobile device, which I've enrolled as part of my identity. I can use email, text, SMS, phone, whatever you want. Here I'm going to use the mobile authenticator, and here's my actual phone. And you'll see that a prompt comes up and it says, Centrify is sending you a notification that someone's trying to authenticate as you right now from this location. Is this actually you, or is it not? Right? In this case, I'm going to hit approve, and without having to type a code or anything else, the authentication completes in the back. Right? So that same concept can then be used throughout everything, whether you're gaining access to the Ambari console from outside, whether you're trying to log in as cluster admin from a putty session. We can integrate that type of mobile device integration across the board. And so we have that capability as well. And then lastly, we have what we call our privilege service, which again is like a vaulting solution. So here, we can manage all the leftover accounts, right? So we already talked about Active Directory identities using our Active Directory bridge. We're using Kerberos for all the SPN accounts for that, but there's still a root account sitting on each node, right? You may have other application accounts that you've created that are sitting on each node, and if those are shared accounts, not tied to an individual user, then you have the, the open door for abuse. Someone can log in as root, or that root can be compromised, and then they would have full keys to the kingdom, if you will. And so, one of the real bad habits that many organizations adopt is they'll use a single password across all of their systems. So when they create a new Linux system, it's part of a template, and root gets configured with the same password on every single box. Or if you're talking about Windows systems, the same local administrative account has the same password everywhere. Right? And so if that password is compromised, the user now has complete lateral movement to go anywhere it wants with highly privileged account access. And so using this type of tool set, we can place those accounts under management on a per resource basis. Right? We can take all of our individual servers, we can import the root or administrative account and give it the initial credential, and then it will go off and create a highly complex, unique password for each system. And if we need access to that information, we can either check in, check out, or we can use this for secure remote access. Maybe I'm a user, I need to get to one of my Hadoop nodes, and so from home or from anywhere, right, I can come into here and I can go to my actions, and I can pick and choose, what I want to do. I can even build in workflow. So maybe certain accounts require a secondary approval. My manager will have to give me access to check out or to log in with that highly privileged account. But maybe certain accounts are given to me by default, right? Where I can do a checkout, do a display, and then I'll have this highly, complex password for the next 60 minutes to use, right? And then when I'm done, I can come back in and check it out, or check back in rather, and it's going to go off and change the password again. Right? The other option is I can actually just log in directly as that user without giving me the password. So I could go back to Actions, right? And if I click Login, what it's going to do is it's just going to simply open up a Java-based RDP session in this case to my Windows box sitting behind a firewall in California. So now again, I didn't need a VPN, and I was able to get to my system and do my work. And so for the Hadoop environment, again, if you need to do like a Linux box, going to there to have a job submission or to analyze the box or troubleshoot in some way, giving them this level of access through a jump box scenario or through a portal could be very beneficial, not only for secure remote access, but securing all of those non-human accounts as well. So you can see how we put the pieces together where the bridge is really meant to manage all of your various human accounts. And then you have the privilege service for dealing with non-human accounts, and then we have the identity service for dealing with all the various SaaS applications that may exist inside or outside the organization. And so putting those pieces together allows us to have a very full-featured, robust security layer that works well beyond what comes out of the box in Hadoop. So with that, I'm going to go ahead and open it up to questions, and I'm sure you guys are going to want to talk about certain topics, so we'll go ahead and do that. Any questions, anybody? Okay.
Yep, looks like there's no questions at this time, Mike. Thank you very much for your presentation. It's greatly appreciated. We'll be having our Vandis account managers follow up with all the attendees and looping in the necessary Centrify resources.
Great. Well, thank you, everyone.
Thank you, Mike. Everyone for attending. Take care. Have a great day.